Cylinder is a solid with congruent circular bases that lie in parallel planes. The height of a cylinder is the perpendicular distance between its bases. The radius of the base is a radius of the cylinder. In a right cylinder, the segment joining the centers is perpendicular to the bases. All right, so for the cylinder, we can see the base is a circle, and the height is the distance between the two bases. So if I were to draw the height inside the cylinder, if I were to draw the height like that, and that would be h, and then I can draw in the radius on one of the circles, okay, and it basically is going to make a right angle with the bases on the top and the bottom. So the height is the perpendicular distance, and the bases are circles. And this whole thing is called a cylinder, okay? So that's a cylinder. And in real life, if you were to think of an example, you could think of like a soda can, and that would be a cylinder. So here they're showing you how to get the formula for the surface area, okay? So we know the distance around this circle right here. That's called the circumference, okay? And we know the formula for circumference is 2 times pi times r. So that's just your circumference. Now, when you unroll the soda can or the cylinder to get the surface area, this distance right here around the circle is going to be this right here. So that's your circumference. And the distance, the length of this thing is just going to be 2 times pi times r. All right, and we know the distance between the two bases is called the height, h. All right, so if we wanted the area of this rectangle here, that area would just be length times width, or base times height. But we see the length right here is 2 pi r. And we see the height right here is h. So the area of this part in blue is just going to be 2 pi r h. All right, and we know the area of a circle is just pi r squared. All right, but there's two of them. There's two circles on the top and bottom. So, as a result, the surface area for a cylinder is going to be pi r squared times 2. So that's 2 pi r squared. Plus this area in here, which is 2 pi r h. All right. So really, it's the same as the surface area for the prism. If you remember the surface area of the prism we just did, we said that was 2 times the base plus perimeter times the height. And the base in this case is a circle. So the area of the base is just pi r squared. So this part right here is your base. And we know the perimeter around a circle is called your circumference. So this right here is your circumference, and that matches the perimeter. And of course, the 2 is right there, and the height is right there. So it really is the same formula for the prism and the cylinder. You just have to plug in the area of the circle and the formula for the perimeter or the circumference. It's the same thing. So they say surface area of a cylinder, it's 2b plus ch. All they did was plug in C in place of P, because your perimeter is called the circumference on the circle, and it's 2 pi r squared equals 2 pi r h. I do not like remembering extra formulas, so I like to think of it as 2b plus ph, just like we did before, and then you just plug in the pi r squared for b and the 2 pi r for your perimeter or circumference C. Same thing. Okay, example 3, you're wrapping a stack of 20 compact discs using shrink wrap. Each disc is cylindrical. It's basically a cylinder with a height of 1.2 and a radius of 60. What is the minimum amount of shrink wrap needed to cover the stack of 20 discs? All right, so they didn't give us a diagram, they just gave us a picture, but I'm going to draw on it anyway. The height is 1.2 millimeters. So if I were to draw the height from top to bottom, that's my height, and I'll just label it as 1.2. Okay, and they said the radius is 60 millimeters. So if I were to draw in a radius right here from the center to the circle itself, that's going to be, the radius is 60. All right, that's millimeters. All right, and we're trying to put a wrap on this. Okay, this is basically a cylinder. And I'll start with the basic formula. They said each disc has a height of 1.2 and there's 20 discs. So for the height, I'm going to have to multiply 1.2 times 20. So for the height h, that's going to be 1.2 times 20 because there's 20 CDs. All right, and now I'm just going to go to my basic formula for the surface area of a prism. That's going to be 2 times the base plus perimeter times height. Okay, and the base is the area of the circle. So that's pi r squared because the base is a circle. And the perimeter of a circle is the distance around, that's circumference. That's 2 pi r, and that's times the height h. So please see if you can finish this by plugging in the height and the radius in this formula. All right, so we have 2 times pi, and that's times the radius squared, so that's going to be 60 squared. Plus 2 times pi again, times the radius, which we said was 60, times the height, which we said was 1.2 times 20. All right, I'm going to use parentheses so we're not confused. I'm going to do the whole thing on the calculator and round to the nearest whole number. Rounding off, I get 31,667, and the units were in millimeters. So this is going to be in millimeters squared. Example 4, find the height of the right circular cylinder shown, which has a surface area of 147.08 square meters. All right, they said the surface area is 157.08. We're looking to find the height h. This right here is clearly a radius. Okay, so the radius r is going to be 2.5 meters. All right, so let's start with the basic formula for the prism. That's going to be 2b plus ph. You don't have to write this. I'm just writing it to show you that it's the same formula. Okay, but once you plug in the area of the base b, that's going to be pi r squared. So that's going to be 2 times pi r squared. And the perimeter is the circumference. That's 2 pi r. times the height h. All right. And that's your surface area. So plugging in for S, we can plug in 157.08 in place of S. And that's going to equal 2 times pi times r squared, which is 2.5 squared. And that's going to be plus 2 times pi times the radius, which is 2.5, times the height h. Okay, we're solving for h. I want to get rid of this. I'm going to subtract this from both sides. So that's going to be minus 2 times pi times 2.5 squared. Okay, so I'm going to subtract that. 2 times pi times 2.5 squared from both sides. All right, and it cancels right here. And if you want an accurate answer, you really should leave this alone. So I'm going to leave it alone. 157.08 minus 2 times pi times 2.5 squared. And that's going to equal 2 times pi times 2.5h. Okay, and solving for h, we're going to divide both sides by 2 times pi times 2.5. This whole thing. 2 times pi times 2.5. All right, if you don't want to do this and you get actual numbers here, it's probably okay. It's more accurate like this. So this cancels here, and this mess right here is h. I'm going to do it on the calculator. I'll do the numerator first, hit equals, and then divide by 2 times pi times 2.5. This whole thing needs to be in parentheses. And I get 7.5. Okay, and the units were in square meters, so the units on the height are just in meters. Now, if that was too much for you, I'm going to do this again, but just with numbers rounded off. Let's see if we get the same answer. I think we will. Okay, we have 157.08. And I'm going to do this on the calculator, rounded to 2 decimals. Okay, rounded to 2 decimals right here, I get 39.27. And then I'm going to do 2 times pi times 2.5. So that's going to be 15.71, and we still have h times h. All right, so just subtract this from both sides. And it cancels here. 8 minus 7 is 1. 10 minus 2 is 8. And this becomes a 6. Okay, this becomes a 4. 16 minus 9 is 7. 14 minus 3 is 11. And that's going to equal 1571 times h. Okay, and dividing both sides by 15.71. It cancels here. And rounding off to 1 decimal, I still get 7.5. And that was in meters. And that equals h. So yeah, if you round off, it's still the same answer. It's a little more accurate the way I did it the first time. But this may be easier to digest for some people. All right, please try this one. Find the surface area of a right cylinder with a height of 18 centimeters and a radius of 10 centimeters and round to 2 decimal places. So I'll start you off on that one. We said that's going to be 2b, which is 2 pi r squared. And that's plus the perimeter, which is circumference, or should I say 2 pi r. Circumference is 2 pi r times the height h. Please try it. All right, so this one's just plugging in. We have 2 times pi times r squared. The radius is 10, so that's going to be 10 squared. Plus 2 times pi times r, which is 10, times the height h, which is 18. All right, so this is all calculator work. Use the pi key. And rounding off, I get 1,759.29. The units were in centimeters, so the area is going to be centimeters squared. Okay, last one. They want us to find the radius of a right cylinder with a height of 5 feet and a surface area of 208 pi square feet. All right, so here's the formula, and I'll give you a hint. You're going to have to plug in 208 pi in place of the surface area for S, and you can get rid of that pi by dividing both sides by pi. All right, so plugging in for the surface area, it was 208 pi. And that equals 2 pi r squared, which we don't know, so I'm going to leave it as r squared. And 2 pi r, again, we don't know r, times the height h, which is 5 feet. Now, there's a few ways to do this, but since we have 2 pi and 2 pi, and we have a pi here, and this is even, I am going to divide both sides by 2 pi. All right, this will get rid of a lot of stuff and make it easier. So these are added, and they're both over the common denominator. So cancels, cancels, cancels. Over here, pi over pi cancels, and 208 over 2 is just going to be 104. And that equals r squared plus 5r. Okay, and what we have here is actually a quadratic. So we need to set this equal to 0. I'm going to do minus 104 on both sides. 104 minus 104 is just 0. So we can factor this. Okay, you can use quadratic formula or find two numbers that multiply to negative 104 and add to 5. So let's see. We can do 2 times 52, or negative 2, I should say. Those are too far apart. Let's see if we try negative 4. See, I doubled this, and then I'm going to take half of this times 26. That's no good. Let's double this again, negative 8, and then take half of this. It's 13. Okay? And these two numbers add to 5. So I can rewrite this. Since we have r squared, it's going to be r times r, and I'm going to use negative 8 and 13 instead of 5. Negative 8 and positive 13. And that equals 0. Okay? So negative 8 times 13 is negative 104. And then solving for r minus anything times 0 is 0. So this can be 0 and this can be 0. And if r minus 8 equals 0, then r equals 8. And if r plus 13 equals 0, r is going to be negative 13. Okay, now can the radius be negative? No. So this right here is the final answer. And the units were in square feet. So the units on the radius are just going to be in regular feet. So that last one was a tough one.